Hello, everyone. If you can see the screen, say yes in the chat. If you cannot, say no. Okay, yes. Very good. Let's begin then. Okay. So today is lesson 3 of the conic sections. Our schedule today, we're going to go over homework, go over the review, and then we're going to learn about ellipses. Okay? So this is the first question of the homework here. So I'm going to give you guys a couple moments to post your answers in the homework, of the homework in the chat, and then we can go over it. Okay, so let's start with this first homework question, right? So it says, write the equation of the parabola that has a vertex 0, -5, and a focus at 3, -5. So how do we do this? So we have the vertex 0, -5 here. And the focus is 3, -5. So obviously, since the vertex is at 0, -5, it's going to be x. Well, it depends actually, because we don't know what way the parabola goes yet. So, since we know that the distance between the vertex and the focus is p is equal to 3, and therefore the directrix is right here. So, therefore, graph looks like this, and you're going to have a parabola that goes right. If you have a parabola that goes right, then y is going to be squared. So it's going to be y plus 5 squared is equal to 4px. And p here is 3. So it's y plus 5 squared is equal to 12x. So that is the equation of the parabola. I'm going to give you another couple of minutes to do this problem and put your answer in the chat. All right, so let's go over this one. So we graph x squared is equal to 24 y plus 2. So obviously, the vertex is going to be at 0, -2 here. And for p, we can compare that to 24. Therefore, p is going to be equal to 6. Right. So if we have the vertex here at 0, -2, vertex is here, p is 6. So which way does the graph open up? You can see since x is squared and it's and p is, and this here, 4p here is positive, then we can see that it is opening up. So we have the focus 6 up here. It's going to be a pretty wide parabola, right? And in directrix, it's going to be down here somewhere. Okay, so that's how you graph it. So first thing you need to do is you need to find p, right? Then you can find the vertex and graph it. So our last homework problem here. Okay, let's go over this one. So for this one, you need to put it into the parabolic form. So what you need to do is need to what you need to do, you need to complete the square, right? So what you get here is you get y squared minus 2x plus x minus 1 is equal to 0. So going to have y squared minus x minus 1 is equal to 0. So then you have y squared is equal to x plus 1. So I think this, I mistyped this. This is supposed to be an x squared here. So I think that's what was supposed to happen, but I guess we'll go with this. So for this one, it's same thing. You're still going to get basically similar solution. So this one, y squared is equal to x plus 1. Obviously, this opens right, and the vertex is going to be at negative 1, 0, right? It's going to be at negative 1, 0. Okay, and p is going to be equal to 1. Well, 1/4. Okay, so then what we have here is something like this, and this is a very skinny parabola that's going right. So now let's review the formula of a parabola. So the formula of a parabola is going to be what? It is going to be x squared is equal to 4py if it's going up. Or it's going to be x squared is equal to negative 4py if it's going down. So these are the parent functions, right? Y squared is equal to 4px if it's going right, and y squared is equal to negative 4px if it's going left. And of course, you can have x minus h squared is equal to 4 plus or minus 4py minus k. So this is just moving the vertex. And also have y minus k squared is equal to plus or minus 4 px minus h. So this is also moving the vertex. So hk is the vertex, and changes to that just moves it, right? So there's not much big of a difference there. Just make sure you know that part. Okay. So let's see here. Let's go over ellipses. So let's see. We can have the definition of ellipse is a set of points P, X, Y in a plane such that the sum of the distance from P to two fixed points is called the foci, is constant. Okay, so let me draw one for you. What exactly is an ellipse? So an ellipse basically just looks like an oval, right? So we have a couple points here. So let's call this negative a0. This is a0. And let's call this 0b and 0 negative b. All right, so obviously this distance is b and this distance is a. So now we can have C, which is the foci C0, and this is negative C0. Okay? So that is basically what an ellipse looks like. And this is the larger axis. That's why it's called the major axis here. Smaller axis is called the minor axis. Right? So then what we have is our equation here, x squared over a squared plus y squared over b squared is equal to 1, right? So then we have, that's our equation, and we need to find a and b. The one thing about this ellipse is it's going to have a squared always bigger than b squared, right? So a squared is always the major axis. Therefore, a is always the major axis. You can see that the length of the major axis is 2a, right? And the length of the minor axis is 2b. And no matter what, basically, no matter what, if a is going to be the denominator for x squared, then the major axis is going to be horizontal. If a is the denominator for y squared, then the major axis is going to be vertical, because a is always bigger. Therefore, whatever number it's under, it's going to affect the shape of the major axis. And the foci are always okay on the major axis. Right? But I'm just gonna let you write that down for a moment. So make sure you get all of this in your notes. Right? So if you haven't started taking notes yet, make sure you start taking notes now. I'll give you a couple moments to put this into your notes, and then we can continue, because ellipses are quite confusing once you get into it, but they're quite similar to hyperbolas. So when we learn about hyperbolas, it should be pretty similar. Okay, so hopefully you got that into your notes in this like 1 minute period. Okay, and then one more thing that you need to know is you need to know how to find C, to find the foci. So C is always going to be equal to a squared minus b squared. So look at this. That is just a property of the ellipse. C squared is going to be equal to a squared minus b squared. Now don't get this confused with the Pythagorean theorem. So make sure you know that it is c squared is equal to a squared minus b squared, not a squared plus b squared, because that is the Pythagorean theorem. and this is not exactly that. So make sure you do not get that confused. C squared is equal to a squared minus b squared, and a squared, remember, is always the bigger one. So let's actually go over the formula for the ellipse. Right now we have x squared over a squared is plus y squared is over b squared is equal to 1. And what we can do is we can actually move the center. You can move the center, right? So of course you're seeing this again. X minus h squared plus y minus k squared over a squared and b squared is equal to 1. That is how you move. That's how you move. You move the ellipse. Okay? So make sure you get this formula down, and it always has to be equal to 1. So if it does not equal to 1, make sure you make it equal to 1 by dividing all sides by an integer usually, right? So let's do this first problem. X squared plus 4y squared is equal to 1. So I'll give you a couple moments. Look back at your notes and try to graph this ellipse. Make sure this is equal to 1, right? And here it's already equal to 1. So that's great. So I'll give you a couple moments to graph this. All right, let's go over this one. So let's see here. So this is very good. This is quite nice. So let's look at our equation here. So usually we have x squared over a squared plus y squared over b squared is equal to 1, right? So obviously, we don't have any vertex changes here because there's no x minus h or y minus k. So you see 4y squared is going to be equal to y squared over 1/4, as you can see here. So therefore, b is going to be equal to 1/2. And of course, x squared is over 1. So let's just repurpose this equation. X squared over 1 plus 1 squared plus y squared over 1/2. Squared is equal to 1. So obviously, a is on the x, meaning that the major axis should be horizontal. We know the center is at 0, 0. And you know what c is? C squared is going to be equal to a squared minus b squared. So it's going to be 1 minus 1/4, which is 3/4. So obviously it's going to be equal to square root of 3 over 2, right? So we have 1 here, 1, square root of 3 over 2. That's the foci. And this is 1/2. And if you piece that all together, you should have your ellipse. Should be pretty skinny, so let's look what you have here. And this is perfect. So make sure next time you also get the foci in, because the foci are very important. It determines what shape it looks like, right? So now let's do this next one. So this one you actually need to complete the square. Make sure you complete the square first and then put it into that ellipse equation and then do it. Right, so I'll give you a couple more. Okay, let's go over this one. So let's see here. Let's just go and complete the square, right? So you see how you have 9x squared plus 36x plus 16y squared minus 32y minus 92 is equal to 0. So we basically pair them up like this. So first, of course, move the integer here. Get this is 9 times x squared plus 4x plus, and this is 16y squared minus 2y. Okay, so then you complete the square. X squared plus 4x plus 4 plus 16y squared minus 2y plus 1 is equal to 92 plus 36 plus 16. You have 9x plus 2 squared plus y minus 1 squared is equal to, what is that equal to? I have no idea. But it's like 144, I think. So now you are going to have to make this 1. By dividing everything by 144, you get x plus 2 squared over 16 plus y minus 1 squared over 9 is equal to 1. So obviously, a is equal to 4, b is equal to 3, c is going to be equal to 16 minus 9, right? Then you square root that, so obviously c is going to be equal to square root of 7. So what we have here is we have at -2 here, and at 1 here we have our center. We create this new axis here. And we have 4 here, and 3 here. And of course, foci are somewhere inside of there. So obviously, the main part here is just trying to get the equation. But the graph is pretty easy, right? So try to get the equation fast. And our third question here, try to solve this. Write the equation of the ellipse with foci at 3, 2, and 3, 8, and end of the major axis at 3, 10. Okay, let's go over this one. Write the ellipse with foci at 3, 2, and 3/8, and end of the major axis at 3, 10. Obviously, if the foci are like this, then you're going to have the center at 3, 5. So we have a center right here at 3, 5. Right? You have 3, 2 here. That's not 3, 5. We have 3, 2 here and 3, 8. So this is center, and we have the end at 3, 10. So obviously this distance is 3 and 5, right? So since this is the major axis, right? Since this is the major axis, 2a is going to be the length of the major axis, which is 10. Obviously, a is going to be 5. And we know that c is also equal to 3. So 9 is going to be equal to 25 minus b squared. Then you can see that b squared is equal to 16 and b is equal to 4. So since the center is at 3, 5, we get x minus 3 squared plus y minus 5 squared is equal to 1. And that's going to be over 25 and 16. So that's the equation. And that's all for today, actually. So a little bit shorter than usual, but ellipses are pretty easy to learn once you get into it. So, and I'll post the homework shortly and the recording too, and I'll see you guys next week.